still have a minute to start. So in some books there's a prologue. I'm going to give you the prologue. So this talk was originally like an hour talk that I gave in December at an Elisa workshop, but at Elisa they told me once I got there I only had about 30 or 35 minutes, so I had an hour's worth of slides. I submitted it for Open Source Summit for here, and I submitted it as a 40-minute talk, and they said, no, you get 10 minutes. So I have boiled down the essence of an hour to 10 minutes, okay? And in case you have more questions, they said to me on Friday, they said, hey, we had some speakers cancel. Could you give us another talk? Or could you make your 10-minute talk 40 minutes? And I still wanted the challenge of 10 minutes. I'm going to give the full 40-minute version in Amsterdam. But tomorrow, we created something called an Automotive Birds of a Feather session that I'll be leading. And we did this at FOSDEM, and we had a lot of people get together. The room was very full, and we just had a discussion, and people brought their ideas about how to advance automotive, open source in automotive. So that is the end of the prologue. We can now go to the main part of the talk. I'm assuming most of you might know a little bit about AGL, but I can't assume everything. So here we go. What is AGL? We are I'm Walt Miner. I removed the intro slides. So I'm Walt Miner. I'm the community director for Automotive Grade Linux, and I also manage our contractors, and I do shipping and receiving, and a little bit of everything. We're a nonprofit under the Linux Foundation, open source project. Our tagline is we're collaborating to build the car of the future through rapid innovation by uniting the automotive and software industries. And we have device profiles that span infotainment, instrument cluster, heads-up display, telematics and connectivity. We're working on functional safety, and we're hoping eventually to support ADAS. Oops, wrong way. We have 9 OEMs that are members of AGL, as well as a large number of Tier 1 suppliers. And we've all been collaborating for about 10 years. I've been the community manager, project manager for almost 11 years. It'll be 11 years in August. And since 2018, we've had millions of vehicles on the road shipping with AGL, including the entire Toyota and Lexus line. So, and then this is my intro material before we get to the lessons learned. We have some expert groups that work on things. We have an instrument cluster expert group that has multiple instrument cluster configurations, including bare metal Linux, container, and virtual machine versions, VM versions. We have an IVI expert group, same thing. It's led by Toyota. They've brought embedded Flutter into the vehicle. So we have both Qt and Flutter versions of our IVI and our instrument cluster. And then we have headless devices, this gateway collection device, telematics device. So, brief history of AGL. It was formed in 2012. And at the time, it had automotive OEMs like Toyota, Nissan, Hyundai, Jaguar Land Rover. And this is kind of predates me. I joined the project in 2014. The first 2 years were really bifurcated. We had JLR doing one thing, and we had some guys in Japan doing a completely different thing. And I came on board, and it was like, what is going on? So Dan Cauchy came on board as executive director in 2014. He brought me on board about 3 months later. And we made the decision in 2015 to create something called the Unified Code Base. That's the distribution that we put out. At the time when I joined, we were using Tizen IVI. Tizen's still around. The IVI profile died an ignominious death. And it was using OBS, Open Build System. I think it may still, I'm not 100% sure. And in 2015, we made the decision. There was a meeting in Santa Clara. We had a lot of people there. And we made the decision to move from Tizen and Open Build System to creating our own distribution using Yocto. We held our first all-member meeting, which was at Tokyo's facility in Ikebukuro, or Toyota's facility in Ikebukuro. And we had an IVI system specification that was released. We had about 60% member growth. So we introduced the UCB, and about 6 months later, we did our first release. It was called Agile Albacore, because they said, UCB 1, that's not very exciting, so I came up with the idea to start naming them after fish. So, and then this is kind of the last introduction slide here. Basically, a bottom-up approach. We have an advisory board, we have a steering committee, which is more technical focused. We have a system architecture team, which kind of owns the overall architecture. And then we have individual expert groups. And expert groups can run projects, they can just be in charge of maintenance, like we have a continuous integration and automated test expert group that's really in charge of keeping our CI/CD running. So, as you may have figured out, lesson 1, get everybody on the same page. Like I said, it was very bifurcated when I started. JLR guys were working on something, they had thrown a bunch of specs over the wall. The other guys in Japan were doing something else with the spec. My recollection was 15 to 20 different mailing lists, most of which were unused or had 1 or 2 posts on them. So you couldn't really figure out what was going on in the project by looking at any one place. So we cut down to a single developer mailing list at that time. And really, I've used the rule since then that we've added new mailing lists very sparingly. And I can tell you, I think we've really only added 1 expert group specific mailing list, and that was for our OSPO expert group. And like I said, initially, a lot of these guys were focused on writing spec with no clear owner or coordination. So when I came along, we pushed to get that spec done out the door. We were using some awful tooling that wasn't open source. I don't even want to talk about it. We had guys working on code, but they weren't working on anything that we could actually use. It was really a very strange situation. So get everybody on the same page. That's why we created the UCB. So what is the unified code base? Basically, I used to work at Continental Automotive. I created what we would call the OSPO there and launched the first Linux products to Mercedes-Benz back in 2010, 2011. For that, I worked at Motorola doing Linux Java phones. And kind of the lessons learned were not only unify the best of open source code, but unify open source developers with automotive developers, because the automotive guys really know cars really well, but they generally have had their heads down on cars. And the automotive and the open source guys, they know audio really well, or the kernel really well, or graphics really well, but they know nothing about cars. But I found at Conti, I had a really good experience hiring up a team where I basically took some automotive guys that were there that were learning Linux and had done some proof of concept stuff, and hiring in some open source talent, and we had a really amazing team there. The thing that we did here was not just bringing in that open source talent through contractors, but we wanted to take what was the best of open source that was already out there and try not to reinvent the wheel. And you can see today, this is kind of the picture of where we are today. We're using Yocto, we use systemd for application management and for initialization. We use Pipewire and WirePlumber for audio. We use Kuxa.val for our connectivity solution. That's the Covisa vehicle signal specification. And we are using Jenkins and Flutter. This is the 20 releases. This is part of the 20 releases we've done. We've done 2 releases every year for 20 years. It's an eye chart. Lesson 2 is, from what I just showed you, embrace change. Most people hate change. I hate standing still. UCB is dramatically different in 2025 than it was in Agile Albacore. We're about to release terrific tuna. No, trout. It was going to be tuna, but we found that there was another package called tuna. We had build conflicts. So terrific trout. And really, but the change should be organic and via new or maturing technologies. And what we did, this is just kind of a picture that shows how we evolved over the years. And let me just take audio as a quick example. When we started, we were trying to use the Covisa, the Genevi Audio Manager and Pulse Audio. It had a lot of flaws to it, a lot of missing requirements that we just there were use cases we couldn't do for automotive. We decided to create our own audio agent because there was nothing else better out there. We created this thing called the AGL Advanced Audio Agent, or the 4A. That was a homebrewed thing. It was really going to be difficult to maintain. And eventually we worked with the guy, Wim from Red Hat, who created Pulse Pipewire and drove a lot of automotive requirements into Pipewire. Eventually, they created WirePlumber as the manager, the system manager, or the priority manager rather. And basically, we were able to work with those open source experts to create something that is usable for everybody and has really helped the desktop side as well. That basically, we changed from an FTE donations to a cash contribution model in 2015. We found it was easier for our companies to donate cash than developers. We engaged package maintainers to close the gap, and we evolved the UCB as we went. I'm going to skip these because I'm running short on my 10 minutes. Lesson 3, educate the industry. Very few automotive OEMs or their Tier 1 suppliers had an OS contribution process when we started. The same is probably true for aerospace companies and their suppliers and medical. It's still very hard for automotive companies to contribute code. We now have an OSPO expert group. We're trying to fix that. But we've had 2+ year waits on contributions to materialize, where a company has said to us, we want to give you XYZ. Oh, but we need to go get approvals. And it's taken, in some cases it died on the vine and we never saw it. And in some cases where we did get contributions, it took over 2 years. So we've got numerous resources. So we've now created this OSPO expert group led by Toyota. We could talk about that some more in the BOF if you'd like. Lesson 4, engagement. Engaging outsiders is hard, but it's worthwhile. There's this common open source myth, and it really is prevalent in automotive circles, and I think it's hopefully mostly died, but there's hundreds of developers out there waiting to volunteer for your project. You just need to find them. What we found, you really need to find the few that really are out there and clear the way for them to contribute. We've had some really wonderful contributors who just kind of materialized out of the blue and contributed for a couple of years, but you understand, people's lives change and they go away, and it happens. But there's not this huge backlog of people. Embedded development is just so different than what most people want to work on. We make multiple channels available for engagement. We have email lists, like I said. We used to use IRC a lot. We don't. We switched to Discord. We find a lot of younger people especially engage very well on Discord. Slack, we have a weekly developer call that I run. Anybody can call in, ask a question. We try to help them. And we try to run meetups. And finally, real automotive hardware is very expensive, thousands of dollars. We need to find lower cost hardware, like Raspberry Pis, BeagleBones, or emulators to get people started. And I think we've done an okay job. We make pre-built binaries available for QEMU emulators and for Raspberry Pi and BeagleBone. Last lesson, lesson 5. And this is a lesson we're still learning. It's a lesson that I've learned painfully many times over the years. Dev boards are not production boards. So even though an automotive-focused SoC vendor like Qualcomm or Renesas or Intel may provide a dev board, what actually goes into the car or the plane or whatever doesn't really look anything like that. So even though we're code first, we do at the end of the day rely on vendor kernels for our BSPs for the dev boards. The Octo kernel updates are very slow. So we really need to solve, and this is a problem I've been trying to figure out for 10 years, the lag in BSP updates from LTS kernels to automotive hardware. And really there's even that gap between LTS kernels to the dev boards, which we're supporting, to how do we then enable Panasonic or Honda, I'm just pointing at my friends over there, to get their real hardware updated for their device trees and their device drivers. And that's a problem that we still need to solve, and I think every embedded industry needs to solve. And that's it. My time is up. I'm probably over time. I'll be here all week, or at least until the end of the day Wednesday. So thank you.